So the steps we take.
Okay, steps, if your foot's on the brake, yeah, go ahead and turn the key. And turn it all the way like you're going to start the engine.
All right, so
there you go, and let go of it. Yep. And that last red circle, you'll see now. Perfect. Now you can take the handbrake off, yep, because we don't have a parking brake right now. Drive, and you're ready to go.
That's never going to get old, you know?
Oh, I know. Isn't that fun? Just
that acceleration, and I mean, I have driven a Tesla, and I think that's the closest comparison to this one. Same, size, all electric, got all that things. But you were just talking earlier about the difference in the battery. Tell us a little bit about the difference in battery structure that you have set up between this car, well, the Chrysler powertrain, and, for example, what Tesla's doing.
Yes, Tesla still unfortunately has the cylindricals in their battery pack, and they have very large quantity, right? They have like almost 7,000 batteries tied into theirs. What we've done is worked with a larger format lithium-ion prismatic cell, standardized the modules so that we can put them across our whole portfolio of vehicles. So we've standardized now on a module. We can do different series and parallel combinations, work to a nominal voltage. We have a 380 volt nominal voltage on this vehicle, and therefore we have 10 modules within our pack. So the failures right away are dramatically reduced over something that you would experience in a competitive product, such as Tesla with their 7,000 connections, if you will. We have a family of motors that can go from 100 kilowatts up to 200 kilowatts, all within the same package space and same envelope. So we're able to adapt that to every one of our vehicles, whether it's rear-wheel drive or front-wheel drive.
Rear visibility is a little tough.
It is. We do need to look at improving that package final when we come through. Obviously, the battery pack, the charger we're looking at will improve, and we'll get that sight down a little bit. But it is pretty narrow to begin with.
Right.
So,
yeah, as you're working on redesigning, you talked about safety feed. You talked about the charger. Like, what are some of the steps that are going to happen now to make that refinement?
Actually, throughout the development plan, we have many vehicles planned for all kinds of testing. But I mean, from a refinement, besides doing at the proving grounds testing, we are doing quite a bit of work in the dyno. So it will be looking at the inverter. What can we do to control, frequency that comes out of the inverter, some of the power into it, and leveling that out. We are trying to see what we can do to smooth out engine mounts. I think we've worked on. We'll continue to look at refining that maybe as we move on. But there are other initiatives in place by our NVH team that they're looking at how can we better refine that, based even off of our experience with the hybrid.
Right there, as we came to a stop, I take my foot off the gas, or off the accelerator, whatever the correct terminology is in an EV, and it felt like the regenerative brakes or something's kicking in pretty solidly.
And that's another. We have the regen is adjustable, so that's something that we can continue to refine, and we need to do more customer synthesis really to just make it a more mature product. We do have a very strong or aggressive regen on it right now, but I guess some people, at least like myself, enjoy that. I like it out of a performance car having that kind of strong regen.
About how many of these prototypes exist right now? Of the Dodge EV?
Actually, right now, I guess I'm not at liberty to say, but we have multiple vehicles under development.
Okay, that's so at least two.
Yeah.
Multiple means more than one.